All right. This is really weird. Got like 6 kids in here. So, oh, I actually do have 6. So, hola, clase. You ready for this? So, today we're doing 5.2 piecewise functions. So, I can graph piecewise functions. We've technically done piecewise functions. You guys are going to see this. It's just where functions have different rules for different intervals. So, we did this on Desmos where you guys had to put like x was less than or greater than a thing, and then it cuts your graphs off. Remember that? Mm-hmm. That's what we're doing. So the first question just says, how is f of x equal to 2 absolute value of x related to linear functions? Well, we learned that a is basically the slope, right? That this is kind of the same as slope. Oh, that's a really bad S. We also kind of learned that like h and k, oh, it's Gradius, but we're going to see if you can answer this. Pause, pause, pause. All right, so what I was going to say was that like h and k was like point slope form. You guys remember that? So where we had y plus y1, well, that's kind of like our k. And then we had, you know, parentheses x minus x1, and that's kind of like our h. So that's where that kind of is similar to those linear functions. All right, so this is a piecewise function. It's where we take 2 functions, but they have intervals on them. That's where these come in. So remember, this is from that Desmos where we had to put intervals on those x's. So the way we do this is we literally just graph the first one and make sure that it stops where x is less than or equal to 2. And then we'll graph the second one and make sure it begins only where it's at 2. Okay, so let's just graph this first one. It's a little bit easier. So we'll go to plus 1. Its slope is 1, so we'll just go up 1 over 1, up 1 over 1. We're going to put a closed dot right here. I'm going to explain this. That's because it's equal to. And then I'm going to stop there with this one because I can't go past 2. You guys see that? So then we're going to go down 1 over 1, and we're going to put as many dots as we possibly can. It's not like the V, no. It can be, but this one specifically isn't. It's just any function. And then I'm going to put my line connecting it. Now, when we go to graph this one, oh, sorry, this one, it's going to start way up here at 6, but technically I can't put that dot because that's at 0, and it has to be greater than 2. So I kind of have to just visually find my next dot. I'm going to go 1, 2, 3, 1, 2, right? Did I count right? Is that 6?
Yes.
Okay. And then I'm going to go 1, 2, 3, 1, 2. You guys see that? Okay. And then 1, 2, 3, 1, 2. I probably should have done this in another color. 1, 2, 3, 1, 2. And then I'm going to connect it there. Oops, I drew my arrow backwards. Okay. Oh, I did totally count wrong. Which one did I count wrong?
The middle one, I think.
Yeah, the middle one's wrong.
It needs to be
the one in the middle, because there's only going to be 2 dots.
Yeah, it needs to be one to the unless we're wrong, but
I don't think we're wrong.
But we're
no, you guys are fine. I did totally count wrong.
Let's go.
Okay.
I feel like my calculations.
This one. I'm good now?
Yeah, you good.
Okay, thanks guys. Well, I knew that too because my line like didn't match at all. I'm like, something's wrong. Okay. There we go. So it does make a V, but not because it's an absolute value function. It's just that it's 2 functions that are now on the same graph that have intervals. Okay? Now, let's do the next one. So I'm going to try to do them in different colors this time. Oops. Why did I just check them with the same color? See, this is the other reason my videos take forever. Because I like to do fun stuff like this. Noia. Oh. I'm just kidding. All right, -2. And then slope's 1. So I'm going to go up 1 over 1. And then I have to stop here because that's as far as I can go. See how it says 1? I'm going to close the... Yeah, so then I'm going to close the dot because it's the equal to. So then we're going to go the other way. And I'm actually going to put this one here too. And then I'm going to connect it. Make it red this time. There we go. All right. So, and notice my line does not go past my dot. So then if I do this one, it's at 3, but I can't put this one here because it can't go over 1. And then I'm going to go 1, 2, 1. Now here's what I'm going to do differently. I'm going to open the circle. And that's because it's not equal to.
Oh.
And then I'm going to go 1, 2, 1. 1, 2, 1. What, Amari? 1, 2.
On the last one, was x is greater than 2?
Yeah, on the last one.
So they connected. So that first one was the closed one. The second one connected to it, so I couldn't show you the open or closed. This time I can clearly show you. So when they connect, it makes sense that that one's closed, but the other one I just can't see.
So only the first one's open.
So this one's open because see how it's not equal to?
Yeah.
And this one's closed because it was equal to.
But like all the dots after that are closed.
No, these can be closed, yeah, because it's a part of my function.
Okay.
It's just this first one that I need to have open because that point doesn't exist in my function, but the rest of these do.
Okay.
Good questions. These are really good questions. And I'm going to make my line purple. But I am going to still like connect it to this dot, you know, like, oops, I did once again drew my arrow backwards, but I don't care. I don't care this time. But yeah, so that's why it was open. On the last one I couldn't see it because they were overlapping. Yeah.
So for this one right here, you have a dot on 1, but it's for the, wait, oh yeah, x is greater than 1 and not equal, but you have a dot on the 1.
Well, so I have it there, but it's open, meaning it's not a part of the function. Remember inequalities where we start there, but it's not actually physically a part of the function?
Okay.
The rest of them are closed now because they're still physically a part of the function.
Okay, that makes sense.
Like solid and dotted.
Yeah, solid and dotted lines. That's another good way to put it.
I didn't like those.
Okay,
Wow, that was awful.
so this is an absolute value function. All right, we know how to graph these. Colton thought we were done, by the way. He just got up and left.
No.
Cool, not about it.
My vertex is at 0, 0. Okay? We know our slope is -3, right? It's upside down. So we're going to go 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. And I get this absolute value function. What it wants us to do is write this in piecewise function. So instead, we're going to do f of x, that really crazy big bracket, and then we're going to write two different functions for these. So like if it's just this line, what's the equation for this line? We just count the slope. 1, 2, 3, 1, 1, 2, 3, 1, and it's at 0. So this is a 3x. And this one is negative, right? But we have to put parameters on the x. So what we're going to do is we're always, whatever one's on the left, we're always going to have it for an absolute value function. We're always going to have it be not equal to. So like this, I would say x is less than 0. Meaning it's dots right here, but it's technically not the closed one. Then anything on the right, and only for absolute value functions, we're going to have it be x has to be greater than or equal to, and this one's always going to be the equal to one. Okay? We'll do an example of this in class so that we can practice that. Okay? But left will always be not equal to, and right will always be equal to for these absolute value functions. And so there we go. Piecewise. Okay. You guys ready for a story problem?
No.
So a gym owner wants to purchase custom wristbands for marketing promotion. She thinks she will need about 75 bands. Her assistant insists that ordering over 100 bands will be less expensive than ordering 75. How can the assistant convince the gym owner? So here's our piecewise. These are our functions. These are their parameters. Okay, so from 0 to 50, it's this $2 plus $25 for shipping. So this is our y-intercept. Okay, we'll go by halvesies down here. Oh no, these are our wristbands. So 10s, 5s? What do you guys want to go by?
10.
10s? Okay, 10, 20, 30, 40, oop, no, 50. I li-
Could go by 5.
No, I don't think it would fit, would it? Yeah. 100's like barely off my thing anyways, right? 10, yeah.
Yeah.
So then these, I think halvesies would work.
Like 5, 5?
That's what a half is, right?
No, they're going by 10s too.
Oh, yeah, that is like.
So 10, 20, 30, 40. I'll just keep it consistent with the book. All right, there we go. All right. I'll do this first one in purple. So the y-intercept's 20. Slope's 2. But the thing is, these go by 10s.
So it's 20 over 10.
20 over 10. Good. Right? 2 over 1 is the same as 20 over 10. Okay, so 20, 10, 20, 10. But how far should I go?
Only up to 50.
Only to this 50, right? Am I even going to make it there? No. Right, I don't even make it there, do I? Okay. So then, this one, it starts at 10, but remember, we can't put that y-intercept on there because it's already been taken over by 0 to 50. We have to get all the way to 50 wristbands first, right? So if we start at 10, we're going to go, it's 1 over 1, so we can do 10 over 10, right? So 10, 10, 10, 10, 10, 10, 10, 10. Now I'm at 50. I'm going to do an open circle at 50 because it's at 51. You guys see that?
50,
50, 60, because I was up at 10 first.
Yeah.
So then I can go 10, 10, 10, 10, 10, 10, 10, 10. And then that's my graph for the second function.
Wait, I got that wrong.
All right.
Not bad.
Now the last one has a no shipping, so it's down here at 0. Its slope is a half, so we can do 10 and then 20. So, but I can't start here because I got to get all the way over to 100 wristbands, which barely fits on my graph. So, we're going to go 10, 20, 10, 20, 10, 20. Did I do okay?
I think so.
10, 20, 10, 20. There we go. 10, 20, 10, 20, 10, 20. And then I'm going to have an open circle here. And then if I go 10, 20, it's going to be over here. Oops. You guys, I can't even connect lines together. Okay. Assistant wants 100. Boss wants 75. How can the assistant convince them? Guess what? You're going to have to do that.
Wow.
Okay. Things to remember. Well, let's add things tomorrow. I don't even know what to put there. Okay, there's your independent practice.
Wait, tomorrow? Thank you.
Monday.
Okay.
Okay, so you guys need to do the independent practice and answer the question to the one I just did.
Okay.
That's it. Bye.